before we start today's class, we need to know homolytic. What is homolytic fission? Ahnaf, oh, no, I think he wasn't there last class, right?
No, sir, I had a headache. Sorry.
Yeah, so you missed an important class. Maisha
Yes, sir. How was the video?
Tasin. Yes, Maisha Tasin. You tell me, what is a homolytic fission? What is a heterolytic fission?
Sir, homolytic fission is the breaking of a covalent bond
Huh.
between atoms which have the same electronegativity.
Shabash. And then what happens? After it breaks down, what happens?
So two reactive species are made which are called free radicals.
Okay, very good. You gave all pieces of information, but homolytic fission maniki. What is homolytic fission?
Sir, homo means the same.
Yeah.
So it means that two elements with the same electronegativity are broken down.
Acha. So yeah, thank you. To me, you explained everything about homolytic fission. But তুমি একটা মেইন জিনিসই বলো নাই homolytic fission মানে হলো যে when two atoms of the same electronegativity is sharing electrons when they undergo a breakdown or a fission. So in a covalent bond there are two electrons, right? So since they're being broken from the center, each electron goes back to their own atom. So তোমাদেরকে আমি মানে you know that I'm very bad with drawing, but আমি একটা শুধু free radical দেখাতে চাই. For example, there is a CH3 free radical. ঠিক আছে? আচ্ছা, so আমরা let's draw a dot and cross diagram across this carbon. So there is a dot and cross here, there's a dot and cross here, and there's a dot and cross here. So দেখো, this carbon has 2, 4, 6, and 7 electrons. It has 7 electrons, right? So Rania, how many electrons does it need to have a full octet?
8.
8. So it just needs how many? 1, right?
1 more, yes.
It just needs 1 more. So this is CH3. Etar hybridization ta ki? What is the hybridization of this? Turabi, what is the hybridization of CH3?
Sir, sp3.
CH3.
Sir, sp2.
sp2. Very good. Ke bollo? Abiaz?
Ji sir, Abhiyazi boleche.
Good. So it's sp2. So sp2 means the hybridization is there's a s orbital and there's 2 p orbitals. And আচ্ছা, so আমি এটাকে একটু erase করি. Let's draw the 3 different orbitals in 3 different colors. Okay, so আমরা ধরে নেই যে S has, so carbon key, what is carbon? Carbon is 1s2, 2s2, 2p2. So আমরা ধরে নিলাম যে the s orbital of, just a moment please. Okay, so আমরা ধরে নিচ্ছি যে 2s2 has 2 electrons, আর So hybridization সময় one of the electrons gets promoted. Anyways, so আমাদের এখানে একটা হাইড্রোজেন, এখানে একটা হাইড্রোজেন. One hydrogen is here, one hydrogen is here. So one hydrogen is here মানে যে ওর একটা electron is being shared. So আমরা ধরে নেই যে একটা red electron আসছে. এখানে আসছে, এখানে আসছে, এখানে তিনটা. There are 3 hydrogens. So there's still one electron who's empty. Mane, who is not participating in any hybridization. So tar mane ki that electron is moving from here to here. উপরে যায় আবার উপর থেকে আবার নিচে আসে. So this is what is happening, right? So since it just has one electron, and sorry, it just needs one electron to have a complete octet. That's why free radicals are very, very, very reactive. Eta lekhe nao. Write it down. I have explained this, but তোমরা এটা লেখে নাও. Do you want me to write it down?
জি স্যার, একটু লিখে দিলে ভালো হয়।
Yes, sir.
So we are studying about free radicals. We are studying about free radicals. Free radicals. So a free radical is a reactive species singular form এর বানান কি?
স্পিসিসই বলে স্যার।
Species বলে, right? Is a reactive species which is formed by homolytic fission. Homolytic fission. The homolytic fission breaks down the covalent bond in such a way that each of the atom present in the covalent bond receive one electron each from the breaks down the covalent bond in such a way that each of the atom present in the covalent bond receive one electron each from the bond. So তার মানে এখানে কার্বন, এখানেও একটা কার্বন. So এখানে a covalent bond has 2 electrons. We need 2 electrons to form a covalent bond. So এখন এই covalent bondটাকে আমরা যদি মাঝখান থেকে ভাঙি, what is happening? Each carbon gets 1 electron each from the covalent bond. So free radicals so homolytic fission only occurs between atoms of the same electronegativity. Why are free radicals reactive? When a free radical is formed, it already has 6 electrons surrounding the central atom, surrounding the atom. When a free radical is formed, it already has 6 electron, sorry, 6, no, 7. 7 electrons surrounding the atom. This means that if the atom, this means that the atom only requires 1 electron to form a complete octet. Complete octet. As a result, free radicals are very reactive and is always in search of another free radical. As a result, free radicals are very reactive and is always in search of another free radical to complete its octet.
Sir?
Yeah.
So when you say they're always in search of another free radical, does that mean like another atom of the same electronegativity, or can it be different?
It may be different. So in O levels, you studied, right? Alkanes react with chlorine to give you a halogenoalkane, right? Do you remember?
Yeah.
So that is a free radical substitution. Acha, so example is CH3 free radical. CH3 free radical. So এখানে তোমরা একটা কার্বন আঁকো, কার্বনের সাথে তোমরা একটা হাইড্রোজেন আঁকো, হাইড্রোজেন. So it already has 6 electrons being shared and there's 1 more electron. So এই ইলেকট্রনটা তারপর কি করবে? So it already has 7 electrons, right? Around the central atom. There's 7 electrons around the central atom. sp2 hybridization. 1 electron is unpaired in a p orbital, making it a very reactive species. So এখন we'll study about types of free radicals. তোমাদের বইতে নাই, but এটা পড়া উচিত। Types of free radicals. Methyl free radical. Methyl free radical. মানে একটা radical which has 3টা hydrogen. Okay. So these are all for organic compounds. Organic compounds. Organic compound ছাড়াও হয়, but so আরেকটা হতে পারে primary free radical. So primary free radical আমরা কি পড়েছিলাম? It's going to be linked to 1CH3, 1CH3 and 1 hydrogen. 2 hydrogen and 1 CH3 with a free radical. So আমার জায়গা হবে না, এই জন্য আমি শুধু secondary লিখছি. Secondary is, so with that free radical, instead of 1 methyl group, you'll have 2 methyl groups. You'll have 2 methyl groups. ঠিক আছে? আচ্ছা, আর obviously আরেকটা হাইড্রোজেন থাকবে। আর tertiary, it's তিনটা তোমার আর গ্রুপ থাকবে। সো এটা তুমি শুধু এইটার জন্য না, সব সময় অর্গানিক কেমিস্ট্রি প্রাইমারি মানে হলো 2 hydrogen and 1 R group. Secondary, it's not just for free radical. The electrophile আছে, nucleophile আছে, অনেক, but everything primary means you have 2 hydrogen, 1 R group. Secondary means you have 2 hydrogen, 1 hydrogen, 2 R group, and tertiary means you have 3 R groups. So tertiary alcohol is actually this. This is secondary alcohol. If you just put a OH, it's going to be alcohol. Acha. So next is এই যে আমরা যে প্রাইমারি পড়লাম, সেকেন্ডারি পড়লাম, টারশিয়ারি পড়লাম। আচ্ছা, এটার মধ্যে এই ডায়াগ্রামটা okay, so I need to draw this again. So here we have
Sir, you're muted.
no, I'm not muted.
Shana, I thought you were speaking.
Sir, do we have to draw this?
You will need to draw this, but now first focus on what I'm saying. Our leg bow এটা। আচ্ছা, now listen to this very carefully. একটু technical জিনিস, so you have to listen very carefully. So here in this methyl free radical, এখানে we have 1 2 3 pairs of electrons with a lone with a unpaired electron. So in total we have 7 electrons, right? Now think about this primary. Think about the primary one. এটা কিন্তু AS A2 দুটাতেই কাজে লাগবে। So here 1 2 3 4 5 6 7. What about this CH3, the R group? এখানে তো this carbon, the central carbon, let's mark it red and it's going to be easier for us. The central carbon is surrounded by 2 hydrogens and 1 CH3 group, a methyl group. Dot and cross, dot and cross, dot and cross. Acha. So if we take the red carbon, how many electrons are around the red carbon?
7.
7. And how many is around the orange carbon?
8.
8. So ekhane 1, sorry, 2, 4, 6, 8. So this carbon already has what? Already has a full octet. Right or wrong?
Right, sir.
It already has a complete octet. Now, তোমার যদি তুমি মাত্র ন্যান্ডোস থেকে খেয়ে বের হইছো হাফ চিকেন, হ্যাঁ, এখন তোমাকে অফার দেওয়া হলো যে লেটস গো ফর আ বুফে in Radisson. তুমি কি will you be willing to go or would you just pass on the offer to somebody else? যতই তোমার ধরো যে you have to মানে you like you are in desperate need of this treat, ও থেকে তোমার ট্রিট নিতেই হবে, you know the circumstances, right? But you just finish a full course meal at Nando's. So তোমাকে যতই lucrative offer দেখ, তুমি কি যাবা? Will you go somewhere else and eat? Is that possible? CH3, the orange CH3 already has 8 electrons, right? তোমরা কি এতটুকু সবাই বুঝছো নাকি বুঝো না? এটা না বুঝলে পরেরটুকু বুঝবা না।
বুঝছি স্যার।
So since the red carbon is one of your friends who hasn't been eating properly or বাসা থেকে বের করে দিছে ওই ফ্রেন্ডকে, বুঝছো? So অনেকদিন ধরে ঠিক মতন খাচ্ছে না, so you pass on that offer to this red carbon. So red carbon কি হচ্ছে যে red carbon needs 1 electron or he is in dire need of another electron, right? So or এই hungerটা কিছু মানে partly it's reduced by the CH3 group. Why? Because it's pushing its electrons towards this carbon. Acha, let me draw this separately. Tale arektu better hobe. So here we have a CH3 which already has 8 electrons. And then we have a red carbon with a free radical. And we have 2 hydrogens. So tale this methyl group already has 2, 4, 6 and 8 electrons around this carbon. But the red carbon has 2, 4, 6 So আমরা এটাকে এরকম একটা করি। So this has 7. This also has, this has 8. So this has 8 electrons, this has 7 electrons. So since this methyl group, this is a methyl group. Since this methyl group is already electron rich, since it's already electron rich, ও কি করবে? It's gonna push the electrons towards this carbon. Why? Because this carbon is hungry for electrons. তাহলে মিথাইল গ্রুপকে আমরা কি বলি আলবা? Do you remember?
Yes, sir.
What do we call this methyl group? Electron donating group. So এখন instead of one group donating electron, এখানে how many groups is donating electron?
2.
2. তাহলে ওর hunger is more than primary or less than primary?
Less.
Less than primary. Acha. And then we have 3 R groups who are donating electrons. তাহলে এই কার্বনের হাঙ্গার কি বেশি হবে নাকি কম হবে?
Com.
কম. So who's the most stable free radical?
Tertiary.
Most stable free radical K? Tertiary. Why? Because he is the least hungry for electron, because since it's surrounded by methyl groups, they're donating electrons towards this carbon. So his hunger is suppose 20%. His hunger is 40%. His hunger is 60%. And his hunger is like 90%. So methyl group is the most hungry for electron. Keno? Because it does not have any electron donating group. Therefore primary is less hungry than methyl group. Why? Because it has one electron donating group which donates electron to the free radical carbon, decreasing its hunger for electron. Therefore next is secondary. Secondary-টা obviously it's less hungry than the primary because it has 2 R groups who are donating electrons. To whom? To the central carbon or the free radical carbon. And tertiary is the least hungry because it has 3 electron donating groups. 3 electron donating groups. So he's more stable. So methyl group is an electron donating group, and since it's electron donating group, it will decrease the reactivity of the free radical.
Heterolytic.
Heterolytic fission. Okay, what is a heterolytic fission?
It, sir, I'm not sure.
Redwan Raza, what is an heterolytic fission?
Sir, it's when a covalent bond is broken between 2 atoms with different electronegativity.
Okay. So heterolytic fission is the break is the uneven breakdown of a covalent bond. This occurs in bonds this occurs in covalent bonds made up of atoms of different electronegativities. Different negativities. So covalent bonded, if we have different electronegativities, it breaks down in such a way that both the electron goes to an atom which has higher electronegativity, and the atom which has a lower electronegativity receives none of the electron. So heterolytic fission gives rise to two types of species. Heterolytic fission gives rise to two types of species. Positively charged electrophile, negatively charged nucleophile. So now we'll study about this positively charged electrophile. So this carbon is the electrophile, and this carbon is the nucleophile. This one carbon, not the chlorine. So now, positively charged electrophile. So actually, positively charged electrophile, আমরা তো last class we studied that there are two types of electrophiles, right? Taiba, what is the types of electrophiles?
Sir, did you ask me?
Yeah, what are the types of electrophiles?
Aren't they positive and neutral?
Yes. Electrophiles can be positive or neutral. So positively charged electrophile কখন হয়? When there is an heterolytic fission. So how many electrons are there? So normally they'll have 6 electrons. So electrophile containing a carbon is known as a carbocation. Or carbonium ion. So we can also write carbocation as a group of atom which contain a positive, which contain positively charged
Sir, what did you write after carbocation?
carbonium ion. Okay, so if you're done, now we'll study about the, done everybody?
Yes.
Yes, sir.
Okay, so now we'll study about the stability of carbocations. So carbocation, first, how is carbocation formed? Formation of carbocation. So we know that carbocations are formed by heterolytic fission. Or heterolytic fission কখন হয়? When the atom is linked to another atom of different electronegativity. So it could, it is, আমরা Cl না ধরে, let's call it X. Okay. So we had a pair of electrons which were shared, and then X being higher electronegativity takes the electron away from this carbon. So eventually what happens? The carbon now has 6 electrons and a positive charge. Why is it a positive charge? Because ওর electrons গুলো তো X নিয়ে নিয়েছে, and X on the other hand is a negative charge. Why? Because it has taken both the electrons from the carbon. So now this is known as a carbocation. So due to difference in electronegativity, the more reactive, or the more electronegative atom pulls the electron towards itself, taking both the electrons in the bond. This causes the carbon to have 6 electrons around it and is deficient in a pair of electrons. Deficient in a pair of electrons. Stability of carbocation. So if you have methyl carbocation, primary. Secondary. Everybody, cameras on. Tertiary.
Sir, आपका secondary बोलो इसे.
Sorry. Tertiary. So, Nashwa.
Yes, sir.
Who's the most stable?
Tertiary.
Shabash. Least stable.
Primary. I don't know.
Methyl carbocation. So in tertiary, they have the most number of methyl groups, and we know that methyl groups are electron donating groups. So electron donating groups causes its hunger for electrons to decrease. Hunger for electrons decreases because they are already donating electrons towards the central carbon. As a result, tertiary carbocation is most stable compared to secondary. So tertiary is more stable than secondary. Secondary is less stable than primary. It's not. Secondary is less stable than tertiary. Primary is less stable than secondary, and methyl is less stable than primary. So stability decreases, or stability increases. So that is the reason primary alcohol ke oxidize korle we get carboxylic acid. Secondary alcohol ke if we oxidize we get ketone, but tertiary alcohol cannot be oxidized at all. No matter how much heat or how much concentrated reagents you give, you cannot oxidize tertiary alcohol because of stability. So এই যে আমাদের যে ইলেকট্রন ডোনেটিং গ্রুপস তাই না এই যে ইলেকট্রন methyl groups are donating electrons to this carbon, methyl group is donating electrons to this carbon. So এই যে electron donating group, this has a special name, or this is known as a something effect. What is the name of this effect? What are they doing? What are they doing? They are
less stable.
they're inducing electrons towards the central carbon. So that's why we call this positive inductive effect.